welcome to The Explainer. Today, we're going to tackle the world of data science. We're breaking down the big core concepts into really clear, memorable points so you can see exactly how we get from just raw data to actual real-world decisions.
I mean, you've probably wondered this, right? How does Netflix seem to know you better than you know yourself? Well, it's not magic, it's data science. And honestly, answering this one question is the perfect way to understand how this whole thing works. It all started with the fundamental building blocks, so let's get into it.
Here's how we're going to break it all down. We're going to cover this journey in 4 clear parts. First, the foundation, the raw materials. Then, the blueprint for building with them. After that, we'll see the incredible things we can actually build. And finally, we'll check out the super powerful engine that makes it all possible.
All right, part 1, the foundation. You know, you can't build a house without bricks and mortar, right? Well, you can't do data science without data. So first up, we have to understand the raw materials we're even working with.
So, what is this big data thing everyone talks about? Well, it's not just about being, big. It's about data sets that are so huge and so complex that your old school tools, like a simple spreadsheet, just completely choke on them. And the real goal isn't just to hoard all this data. It's to dig through it and find those hidden patterns, the valuable insights that let us make way smarter decisions.
To really get what makes it so complex, we can break it down into these 5 characteristics, the 5 V's. Let's use social media to make this super clear. You've got volume, which is just the massive amount, millions of posts every second. You've got velocity, the insane speed it's all happening in real time. Then there's variety. You've got text, pictures, videos, emojis, all jumbled together. Veracity asks, can we even trust all this information? And finally, value. What useful insights can we actually get from all this noise?
Okay, so to make any sense of this data storm, we turn to our trusty friend, statistics. Descriptive stats just summarize what you have, like the average movie rating. Inferential stats let us make educated guesses about everyone based on just a small sample. Correlation helps us see if 2 things are related, like does more study time lead to better exam scores? And probability helps us deal with randomness, which is absolutely crucial for making any kind of prediction. These are the basic tools for turning all those numbers into actual knowledge.
So that brings us to part 2, the blueprint. We've got our raw materials, the data. Now what? How do we actually build something useful with it? Something that can spot patterns and maybe even predict the future. This is where we start building a model.
Let's make this super concrete with a healthcare example. Say a hospital wants to predict which patients are likely to be readmitted soon after they leave. Well, first, you define that exact problem. Then you gather up all the data you can, patient history, lab results, you name it. Then comes the cleanup, getting the data ready. You might even create new clues, like a medication count. Then you finally train your model. And after that, it's all about testing it, putting it to work helping doctors, and constantly updating it to keep it sharp. It's a really clear step-by-step process.
Now, that testing step, validation, is so important. You can't just build a model and cross your fingers. You have to put it through its paces. We use all these different metrics you see here to measure just how good it is. This is absolutely vital to stop a huge problem called overfitting. That's when your model gets so good at the practice questions that it totally fails the real exam. Think of it like a student who just memorizes answers but doesn't actually learn anything. Proper validation makes sure our model is actually smart, and we can trust it in the real world. And this brings us to part 3, the impact. So now we know how these models are built and tested. Let's look at what they can actually do. This is where things get really exciting, where these tools start to change our world.
In healthcare, the impact is just wow. Machine learning models can sift through patient records and predict the risk of diseases like diabetes, sometimes years before symptoms even show up. They can also analyze medical images, like MRI scans, acting as a second pair of eyes for a radiologist to help them spot tumors earlier and more accurately. It's a game changer. Or think about finance. It's pretty much all about managing risk. Banks use machine learning to look at loan applications and predict who's likely to pay it back and who isn't. And your credit card company? They're using it to protect you, constantly scanning for transactions that just don't look right, stopping fraud before it even happens.
And this brings us right back where we started, to Netflix. Recommendation systems are a huge, massive application of machine learning. They analyze everything you've ever watched, compare your tastes to millions of other people, and then they make those scarily accurate suggestions for what you should watch next. It's not magic, it's just really, really smart data analysis.
So that leads us to our final part, the engine.
We've seen all the amazing things data science can do. But hang on a second. How can computers possibly handle the crazy amount and speed of all this data?
Well, the short answer is a single computer can't. Even a really powerful one just hits a wall. As you can see here, traditional tools are like having one single chef trying to cook a feast for thousands of people. It's just not going to work. Big data solutions, on the other hand, are like having a massive team of chefs all working in parallel.
The secret sauce is using these powerful distributed frameworks like Hadoop and Spark. What they do is brilliant, really. They let us divide and conquer. Instead of one computer struggling with a huge job, they chop up the data and the task across a whole cluster of computers. This way, they can all work on a little piece at the same time, in parallel, turning a job that might have taken days into something that takes minutes. Plus, if one machine breaks, it's no big deal because the data is copied in other places.
And this tech has a direct impact on the real physical world. Take a logistics company. They can analyze real-time data streaming in from sensors on their entire fleet of trucks. This lets them optimize delivery routes on the fly to avoid traffic, saving tons of time and fuel. They can even predict when a truck part is about to fail, so they can fix it before it causes a costly breakdown on the highway.
So, there you have it. We've walked through the whole journey, the foundation of data, the blueprint for building models, the amazing real-world impact, and the powerful engine that makes it all run. We've seen that when you use it right, data can actually help us predict what's coming next. Which leaves us with one final, pretty exciting question to think about.